Welcome in MLAC. Today we are discussing TDM, Communication System. First, let's talk a bit about maxes. Let's think about TDMs in depth. Basically, TDM is made to connect two people, two computers, or two things together. I need to connect this wire to this wire in first clock. So I made a counter. This counter counts +1 every clock, so that when I enter 1 here, 0 here, 1 here, 0, 1, 0. For first clock, I will connect this one, the data here, with the data here, because the selector is the counter, so it is 0. So the selector here is 0 and selector here is 0. So it takes this 0 on this wire and then demax out this 0 on this wire. So I connected first wire to first wire, which what I needed to make a contact between the first wire and the first wire in different channels. So it is TDM idea. I need to make a counter, a max, a demax in my project. Now let's make the code for these blocks. First, let's talk about always and case statements. Always is a statement we use to work with blocks. And sequential logic. Always comes with at, in parentheses, positive or negative edge of clock. So this code will execute and change with the negative edge of every clock. Then begin and end. Then case statement is widely used in state machines and also without state machines. Case is I'm telling the FPGA that if S equals 0, do this line. 1, do this. 2, do this, etc., etc. But the default, if it wasn't 0 up to 7, do this line. Okay, and then in case. And this simple we use to work with registers. I'm telling the computer to input the right hand side into the left hand side, which must be registered with this symbol on the clock, if negative edge or positive edge. So in every negative edge, if it is 0, we'll take the first 4 bits in input and put it in output register. Important things to say: every single signal entered the mux is 4-bit signals. So I have 7 signals. Each one contains 4 bits. So this is the max, input clock, input selector, input input, output, output, and register for the output register to change the output with every clock. Always at negative edge clock will begin this code. If selector equals 0, will store the first 4 bits. If the selector equal 1, will store second 4, etc. Now let's talk about demax. Demax is basically do the inverse of this operation. What I say, if it's 0, is how to write integer 0. Sorry, decimal 0. It's how to write decimal 0. And you can simply write this like that. Now, I will fill the output register with the input. Like in the blocks, I will store the first line or second or third, depends on the value of the selector. And then the counter. The counter is so simple. The max of the counter must be 7, so I tell the APGA when number is less than 8 plus 1 to the number. If it is 8, clear it to 0. It is called inline condition, and its syntax is like that. This question mark, this parentheses, the condition. Do that if the condition is true, or that if the condition is false. Okay. Initial begin end. It is the first block compiled in the verilog. So when you start the program, first thing you do is to set number to 0, because number is default to Z. So if you added a 1 to Z, it will not change anything. But now number is 0, so you can plus numbers to 0 simply. Then finally make a TDM simulation to do all this work. And this Z is for compilation, okay? The compiler demands an output, so you can't do a module without an output, okay? So this Z is dump variable for the compiler and always assigned to Z, but it will not affect the program at all. So I define the clock and will change it in this clock simulation by always block. I initialized my clock to be 1 and tell the program always begin, always can be used without a clock by doing this. Put a delay to change or to do the line. This basically means every 10 unit time change, make the clock equal not clock. Every 10 times, it will toggle the clock from 0 to 1 and 1 to 0. 10 unit time. So it is the clock I used. Then the wire link is this wire here between max and dmax. So this wire link is this connection. Selector is coming from the counter, so I will use the counter here, and its output will be the selector. Of course, the clock transmitted is the input of the max, 32 bits, because it is 7 wires. Every one is 4 bit. So 4 multiplied by 7 is 32. And its output is the link line we talked about. And the output of the max is 32. Output, its input is link, and its output is received. And take, of course, the selector and the clock. Now, let's talk about how to call a module. Write its name, which is max8_1, and give it a name. Let it to be u_max8_1. Open parentheses and write your inputs and outputs. This max take input clock, so write dot clock, the name of the variable in the module you call, and the name of variable in this module which you would give to the module. Or you can simply do that without a problem. So it is the inputs, selector if input, and output from the counters, like I explained. Clock is input is input, which is transmitted, and output is link. Same for the max, same for counter. And now initial begin. This block is for simulation actually. It's like a test bench. I change the data every 300 unit time to check if my program worked fine or not. Now let's simulate our code. Running simulation by clicking Tool, Run Simulation Tool, RTL Simulation. By the way, you must compile your code first before simulation. Click here. Do not only simulate the top module, which is TDM simulation, but you must simulate also the called module, the modules you called in your top module. So click simulate, add, did it clearly. We need selector, the link, the transmitted, the received, and the clock. Right click, add to wave, selected signals, and just click run from here. Make it to show in hexa, and like expected, you transmitted 1, 2, 3, 4, 5, 6, 7, 8, and it received 1, 2, 3, 4, 5, 6, 7, 8. Then you change the input to 4, 5, 6, 7, 8, 0, 12, and the output change to 4, 5, 6, 7, 8, 0, 12. It takes some clock to be done because you only change one channel in a clock. That's all we have tonight. Thank you for watching.